Welcome back, Franken friends. I'm Greg Smith, aka Dr. Francintosh, and today we have a very special project. It's an all-in-one Raspberry Pi Zero 2W all-in-one monitor. That's right, we're going to drop a Raspberry Pi inside of a ViewSonic monitor that I salvaged last year, and we're going to be running my PyMirror project in a cluster of 4 of these ViewSonic monitors on my wall. So we'll be using that as sort of a giant dashboard. So stay tuned and check out the next Dr. Francintosh right after this. So our story starts out about 2 years ago when I saw an ad for some free monitors at a local salvage company. I went to look at them and they looked pretty good. So I asked if I could take all of them. They said, please do. There were a total of 20. 16 of them were ViewSonic monitors, like this one here. Like this is the actual monitor. And they came with no power cords and no guarantees. So I brought them home, spread them out, took a nice picture, and then turned out I had 16 of these ViewSonics, and I then went ahead and started cleaning them. And after I cleaned them up, I turned each of them on to try and triage the quality of each of the monitors. And it turned out that I had, I think, 10 that were in good shape, 2 that were in terrible shape, and then 4 that were kind of intermediate. And I created a spreadsheet of it like this. So since then, I've used the 2 that were in bad shape. They both turned on, but they had cracked displays. And I use them for what's called cadaver units. That is that if I have an experiment or a trial that I want to make, what I'll do is I'll use one of those broken units to kind of experiment on. And the first project I did was the transparent monitor, which you can see here. So now on to the next project. The PyMirror project is one I put out last month. And it's sort of a dashboard, a replacement for the Magic Mirror project, which takes too much CPU and graphical resources for my poor Raspberry Pi Zeros. And so I rewrote it in Python and did some custom C code and got the PyMirror project to work. But there are wires everywhere. There's a power cord, there's sound cord, soon to be an IR remote control cord, and also VGA. So that became a problem. There's too many wires, so I decided to put all of that inside the monitor itself, and that's what today's project is all about. So hopefully when we're done, the only wire that'll be coming out is the power cord. So here are our goals for this project. We want to connect the Raspberry Pi's HDMI output to a VGA converter and then funnel that into the monitor's VGA input. We also want to reuse the USB hub on the monitor and plug that in through the on-the-go USB on the Raspberry Pi. We want to channel the sound from the Raspberry Pi into the speakers for the monitor and add a new infrared remote LED to the Raspberry Pi and mount that appropriately on the monitor. Finally, we want to siphon off enough power from the monitor to power the Raspberry Pi. Hopefully, there will be enough leftover current from the monitor that the Raspberry Pi will be able to run with all the power it needs. So here we're separating the back of the monitor from the front, and the shell is actually held together with a bunch of these plastic clasps. Normally I don't use a metal device to open up such devices. Usually you want to use plastic against plastic because metal is harder and it will scratch your plastic. These guitar pick type devices are perfect for this. As you can see, I'm just sort of sliding it along the crack, which causes the catches to release. And there are 4 sides to this. There are 4 edges, and the clasps pretty much let go as you slide this guitar pick device, which I got from iFixit, by the way. And the back pulls off with ease. So now we're going to disconnect the backlight. It's a white LED strip as opposed to compact fluorescent. Over here, we're pulling off some of the backing tape. Before we do that, though, I wanted to go around and just sort of mark where the back part of this fits onto the monitor itself, or back onto the LED panel itself, so that when I come to put it all back together again, I know where everything went. This white wire here connects to the LED, the power LED on the front, and the control keypad on the front. So this metal tape here serves two purposes. It not only holds the chassis against the monitor or the panel display, but it also acts as a bit of RF shielding, and it's pretty sticky. Now this is an LVDS 30-pin flat connector that we're pulling off, and as you can see, this just lifts right off. It's not held on with screws or bolts or anything else. That tape is the only thing standing between us and disaster. So at this point, and we're going to remove that's the keyboard and power LED connector, so we're going to take that off. And now we're also going to remove the power connectors. So what we're going to be doing next is connecting the VGA port to our Adafruit VGA converter. So as you can see with this wiring diagram, we're going to connect pins 5, 10, 8, 7, and 6 together, but we want to jump over pin 9. So what I did was I put a bit of insulation on pin 9 to protect it. And we'll be using wire wrap wire. I've got a nice long strand here. We'll solder it onto pin 5, and then we'll actually use it as wire wrap. We will wrap it around the posts 10, 8, 7, and 6, and that will be our ground connection. As it turns out, pins 8, 7, and 6 are the independent ground connections for each of the RGB pins, which are red, green, and blue. Originally, I had tried to use DVI as an input and connected the HDMI directly to DVI. It turns out that DVI and HDMI are almost the same protocol, but the Raspberry Pi Zero just doesn't have enough current coming out of the HDMI connector to drive DVI, and I hesitantly decided to go with VGA. At first, I was concerned that VGA would not have the kind of color resolution I was hoping for, but it turns out there's almost no loss of image quality. So VGA turns out to be a very good solution here. So what we're going to be doing is actually wiring this up with wire wrap, and then we will wire this directly to the Tcon board where the VGA connector connects to the circuit board, and then this will connect into our HDMI to VGA converter, which we purchased from Adafruit. So I'm going to speed this up now because a lot of this is just me soldering. So I don't know it'll be all that interesting. I'm checking for continuity here, make sure I've got good ground connection. And now we're going to cut it to size. And now we're going to add the red, green, and blue wires. These are, first I'm tinning the posts, so we'll get a good connection. And now our red wire. And our green wire. Now there are also two other wires that I don't show here, the yellow and the orange, which are clock and sync pulse wires. So those will get connected off screen. And we're going to trim our little insulation port. Now, one thing I've noticed, a lot of guys use a lot of resin. And I have to admit, when I started using resin, a lot of my soldering projects became a lot easier, especially when you're soldering on a vintage board like this. The connections are really not very easy to connect to. Also, you may notice that we changed the pin orientation again. So keeping straight which pin is number one is very difficult. Fortunately for us, this board they actually numbered the pins on this side of the board, so it was easier to tell which was pin 1 through 5. I was very worried about noise, electrical noise on these wires, and it turns out because they're so short, we've had very little noise problems in the actual implementation. Okay, so this is all good and done, and it actually looks pretty good. So now we're going to splice in a power connection. This is a 5-volt connection that comes from the main power board. And I'm just going to cut into this and splice our uh, Raspberry Pi's power line into it. Now there are 2 wires here that are rated at 5 volts. And I didn't check, but I believe one of them is switched and the other one is not. And so if you have the power button on the outside of the monitor, will turn the monitor on and off. And I believe that the one that we're splicing into here is always on, which I think we want because we want the processor to be thinking even when the display is turned off. Otherwise, when we turn the display off and we turn it back on again, it would have to reboot the Raspberry Pi. The other wire, the orange one there, I believe is switched so that when the monitor is off, that power the current to that wire is also off. Now there are multiple ways to do this splice. I can't say that this was a very good one. I sort of just cut the wire and then spliced it, and then wrapped the Raspberry Pi's power line around that, and then tried to cover it up with electrical tape. It's kind of ugly, but it actually worked very well. And cut to size. Okay, so this is a hole that we're putting into the metal chassis. We're drilling this hole into the metal chassis for the infrared LED. We're going to put a 1/8 inch 3 hole. So we're going to be putting a tip ring sleeve receptacle in here. It's your basic 1/8 inch stereo plug. One of the challenges, though, we're going to be putting the ground on the sleeve, and then the power on the ring, and then the GPIO port on the tip. And the challenge with that is that I have to be careful when plugging it in because it will short both the Raspberry Pi and the IR LED. So everything has to be turned off when we plug that in. Here I'm cleaning up. I want to make sure I don't have any shards of metal lying around that will cause a short circuit. So I use these alcohol prep pads for practically everything. Here we're wiring up the TRS connector. Again, nothing fancy here. That's ground, and then the red will go to the ring, and then the white will go to the tip, and then the other end of this will go to the Raspberry Pi with the GPIO port, and we're using GPIO 14 in this case. So this all worked out very well. Very pleased with this particular solution. And again, yeah, I have to be careful to remember to turn the entire unit off when I plug in the IR LED, or risk shorting both the Raspberry Pi and the IR LED. All right, so this is one of my favorite connectors. It's a flat USB-A connector. I got these like a dozen of them at the dollar store. They've come in very handy for this sort of project where I want to, use a part of the USB, and so I can cut off one end, be it male or female, and use the other end. So this works out very well. As the charts here are showing, the pin 1 is the VCC or plus 5 volts, pin 4 is the ground, and then the other two pins are data minus and data plus differential signal. And it's very important to get the minus and the plus correct because when you don't, it doesn't get the signals correct. You may notice I've got the female connector for the B USB up here. That is because this has a B input, a USB B input, and I have to get the orientation right. Otherwise, we'll get a short circuit on the power. Ultimately, this plugs into the Raspberry Pi's on-the-go USB port. It's a micro USB, and this worked out very well as well. When we're done with this, we'll be able to plug a keyboard and a mouse into the USB on the bottom of the monitor, and yeah, that'll work out great. Now, this black box that you see over here on the right, that is the Adafruit micro HDMI to VGA converter, and this is a wonderful device from Adafruit. I think it cost me $10, and that's the thing that actually makes this whole thing work very well. This is the sound connector, so this is another 1/8 inch plug, and this will connect to the power board, which also doubles as the audio input board, and so we'll just be piggybacking on that connector, and then this will plug into our HDMI to a VGA connector, which has an audio output. So the Raspberry Pi Zero has HDMI out, and it also sends audio along the HDMI, and so this Adafruit VGA adapter will split out the video and send it down the VGA port, and it will take the audio and send it out the headphone jack. Once again, lots of rosin, and as usual, because this is an older board, adding new solder to make everything stick well. And just solder it right on there. Again, nothing fancy. And I was very pleased with how everything just sort of fit here. Especially with these older monitors, there's a lot of extra space on the inside, and mounting this VGA adapter plus a Raspberry Pi in here was really no problem at all. Lots of extra room. I'm not a huge fan of hot glue in the sense that it doesn't really adhere very well. You'll see in a minute here, I actually rough up the chassis a bit to make sure that everything sticks. But in a pinch, hot glue works just fine. Okay, so I've got some standoffs for the Raspberry Pi. I wasn't able to find Raspberry Pis that didn't have header pins. I have had success with ordering Raspberry Pis with header pins and then using a desoldering tool to remove the header pins. In this case, though, what we're going to do is just use some standoffs and stand the Raspberry Pi off against the chassis. Also notice, again, the use of the alcohol prep pads. I use those a lot for cleaning up the inside of the board. And here I'm just marking the places where I want the hot glue to go. Again, I'm not a big fan of hot glue. I roughed up the surface here to make sure that we had enough of an uneven surface that the glue would stick. But again, this has worked out pretty well for this project, and I'm very pleased with the end results. So there's our Pi, nicely mounted. Okay, so now it's time to connect the power and the GPIO pins. We'll start off with the GPIO. Mind you have to get the orientation right. So over here, what we're doing is first the power has its own. If you can see on the chart here, there's a ground and a 5-volt pin test pad, and then again adding copious resin and then new solder, and now connecting the GPIO 14 pin to the IR TRS connector, the infrared TRS connector. And now, just battening it all down with some tape. You can see here I've connected the USB port to the on the go, and we're basically good to go here. Okay, so we're going to give this a test run, and because the VGA has not been disconnected from the main circuit board, we can actually plug a monitor into this, and we're going to power everything on, and then check to see if the Raspberry Pi powers up and if we get some output on the external monitor, just to see if everything's working. So if everything's working, what we should see on the external VGA monitor is a Raspberry Pi powering up. And here you can see the Pi's light is flashing. That's a very good sign. We'll connect the HDMI to VGA adapter. Now you can see the external monitor, VGA connection, and we're just waiting to see if the Raspberry Pi is going to power up, and there it is. There's our Raspberry Pi going through its boot sequence. So we are in good shape. Everything is working. Power is applied where we expect it to be, and the Raspberry Pi is booting as normal. It's time to put the chassis back on the panel. We put the LVDS connector back in, line everything up with the markings we made earlier, reconnect the backlight display power. Now we don't have our, now the tape we took off is useless now, and so we're going to use regular duct tape to hold everything together. And verifying that the power is not connected. So we're going to connect that. And by the way, I have a power strip over here that I use to turn the mains on and off. That way I make sure that I'm very safe. And checking to make sure everything's solid. And we're going to give this a test. We're going to step back, turn on the power, and hold our breath. No magic smoke. And everything is powering on. This is a very good sign. All right. Now we're also going to test the keyboard, make sure that the USB adapter is working. And we'll log in. And we're logged in. So the keyboard is working, and that's a good sign. All right, now it's time to put it all back together. Make sure everything's turned off. And we'll get the back of the shell. And mind you, these are all just clasps, so make sure it's on the right way. Turn it around. Good boy. Okay. So then it's just a matter of like applying a little pressure and everything just snaps together. So here's how it looks. That stand did not come with it. I went out and got a $20 Visa VESA stand, powered on, and our project is complete. We now have a 100% all-in-one Raspberry Pi. So here I'm actually typing in the install commands. What you see, the little screen there at the bottom is my iPad. And we're just typing in the commands that will install the PyMirror project. So not only am I testing my monitor, but I'm also testing the install script that I use for installing PyMirror that I've published on GitHub. So if everything went well, we should see PyMirror. And there it is. It's loading, it's hitting the internet. So the Wi-Fi is working. It's a 100% good project. So it looks like the Raspberry Pi all-in-one monitor is a success. This is actually the second time I've done this. The first time I did it on the cadaver unit to make sure that everything would work. I made a lot of mistakes. I cleaned those up for the production model. Next time, well, I'll be doing this monitor and converting it to all-in-one, and then we'll be putting two more up there as well. So there'll be a total of 4 monitors. Plus, all 4 monitors will have IR controls, so we can do things like cycle through the slideshows, or if you see a news article that you want to reread, you can hit the back arrow and it'll go back to the previous article. But with 4 monitors on the wall, all of them receiving IR at the same time, I'll need to have some sort of software that I can select which monitor I want to control. So all that's coming up on the next episode of Dr. Francintosh, so be sure to join us. And as always, please don't like this video, don't subscribe to my channel, don't click up there or down there. Your time is precious, but thank you so much for spending part of it with me, and I'll see you next time on Dr. Francintosh.